In this video, I will show you how to simulate rolling dice on the TI graphing calculator. Now for this video, we're going to assume the dice are all six-sided. And certainly there are dice with more or less sides than six, but for now we're just going to kind of stick with the standard six-sided die. And by the way, die is singular and dice is plural. So if we're talking about a single die, then we use the word die. If we're talking about two or more, then we say dice. So what I have here on this slide is what I'm calling an idealized results from rolling a fair die. This is an example of what we call a uniform distribution in statistics. Uniform meaning each of the possible values of the variable, in this case the variable is the number of pips for the particular roll of the die. The distribution shows the expected frequencies for each of those possible values for the variable. So in this case, I just gave an example where the die was rolled 18 times, and the results would be 3 of each number. And that's the idea behind a uniform distribution. Let's pause for a moment and talk about distributions. When I think about distributions, I think about three parts or three things, characteristics that distributions have. The first is that distributions are of a variable. So whenever in statistics or in mathematics or probability theory, whenever you're thinking or whenever you hear that word distribution, one of the things that should go through your mind is the distribution of which variable. The second thing that distributions do is they give all the possible values for that variable. And then the third thing they do is the distribution gives the frequencies or the relative frequencies of these possible values. Now a frequency would be a count. In the previous example, the frequency plot were counts. 3 ones, 3 twos, 3 threes, and so forth. We could also look at those as what we call relative frequencies, either given as a fraction or given as a decimal or even a percent. So for example, we could say the relative frequency with which we would roll a 1 on a fair six-sided dice would be 1/6. So 1 out of every 6 rolls would be the relative frequency. So the relative frequency is relative to the total number of possible things that could happen, in the total number of different ways those things can happen. It can get very complicated, as we'll see in a few minutes here. So to investigate the distribution for a variable, and there are many applications actually for what I'm about to show you, this technique, is what we call a simulation. And the calculator, the TI calculators, the 83s and the 84s, have what we call random number generators. Now the first thing I want to do is talk for a minute about computers and computer algorithms. Computer algorithms are not capable of genuine randomness. And the reason is because they're algorithms, which means for any algorithm, there needs to be some kind of input. In the case of a number generator, the input would be what we call the seed value or the seed number. And if you know that value, then the outcomes are all predictable. Just as a demonstration, if you get out your calculator, and again, you can pause the video at any point if you need to stop and get your calculator or something like that. And I do recommend you go through these steps with me on your calculator, pausing the video as you need to. Now, I'm just going to pick a number. I don't know why 32 pops into my mind, but I'm going to use 32 as a seed value. And what I'm going to do is store this into with something called a variable on the calculator or called rand. Let me show you how to find that. So press math and go over to PROB, stands for probability, and we're going to choose the very first choice, which is rand. Okay, so what this actually says is take the number 32, store it into rand. And on the calculator, variables can be, they don't need to be single numbers. They can be words or a combination of letters and even numbers. So in any case, what I'm going to do right now is store the number 32 in rand. And now what I'm going to do is go through the process of simulating rolling this six-sided die. If you press math and then go an arrow to the right until you get to PRB, you'll see choice number 5. It's called randomint. And randomint is the random number generator we're going to use to simulate rolling this die. And six-sided dice have numbers of pips, right? 1 through 6. So we're just rolling one die this time. The n would be the number of times I wanted to do the simulation, and we're going to change this a little bit, and I'll show you a different way to do this. But for now, we're just rolling a single die. And so I'm just going to choose paste. Now, if you don't have wizards on your calculator, if you're using an 83, you won't see this pop-up window. And I can show you what to do along the way, or I'll do a couple of simulations here. I'll come back and show you. Okay, so, and in fact, let me stop for a minute. So if you have the stats wizards, that pop-up window I just saw, when you press paste, this is what you're going to see. Now, if you don't have wizards, if you have an older calculator that doesn't have that capability, when you choose randint, this is what will pop up on your screen. And what you need to do is just simply type 1, 6. So the wizard is kind of like a shortcut, I suppose, or it prompts you to know what to put into the particular places in the TI command we're trying to execute. Okay, so what this is going to do is give me 1s, 2s, 3s, 4s, 5s, and 6s randomly, quote, I'm going to put random in quotes, okay? What this will do is simulate rolling a die. And we're going to say it's simulating a fair die because the only possibilities are 1 through 6, and the calculator samples from a perfect mathematical uniform distribution. So it's going to give me the 1s, 2s, 3s, 4s, 5s, and 6s with the same frequencies overall, but they're going to be random, so there could be streaks. So I'm going to press enter. That's my first roll is a 6. I'm going to press enter. Next roll is a 3. And next roll is a 2. Next roll is a 1. Okay, so if you did the previous step, the 32 store into rand step before, you should have gotten the 6, 3, 2, 1 I just got here. And that should tell you something. In a truly random process, we wouldn't be able to predict these values. But now we can predict the numbers that we would get from randomint. The first 4 would be 6, 3, 2, 1 if the seed value is 32. Just to kind of illustrate that, I'll show you what I mean. So if I come back in and I redo the command where I'm storing 32, I've got to go back a few screens here. So if I go back to the 32 store rand and do that over, and then do the random int, random number selection again, I'll get 6, 3, 2, 1. So seeding the number generator allows us to know what numbers are going to come up. The thing about it is, if I don't seed the number generator, or even though I did seed the number generator, I haven't memorized the 5th number in the sequence. So I honestly don't have any idea what number is going to come up. Now we call these electronic random number generators pseudo random number generators because they're not true random number generators, but they behave like a random number generator and they work very well as long as we aren't, manipulating the results through seeding the number generator or things like that. In any case, to simulate rolling this die, what I can do, I got 6, 3, 2, 1, and so I can draw a frequency plot now, or start to draw a frequency plot by putting putting x's above each of the numbers that came up. So hold on now, let me look here. Okay, so we got 6, 3, 2, 1. So I would put an x over the 6. I would put an x over the 3, the 2, the 1. Then I could simulate a few more. So I'll get 4 more. 6, 5, 4, 6. And you notice we got one of each number, but we ended up with 2 more sixes out of the first 8 rolls of our fair die on the calculator. And that's how it goes. This is why gambling, for example, is an enjoyable thing, because you can have these streaks, or these lucky streaks, right? There's 4 threes. So again, I'm just rolling this die. Whoop. Uh, let's see. I think that was a 1 and then 3 threes. Oops. And if I continue doing this in the long run, these x's will even each other out. Now they'll typically be, since it's a simulation. If I could do this an infinite number of times, then there would be exactly the same number of x's over each number. But I'm not going to be able to do that. And so there's going to be streaks in the short term. But in the long run, the ratios of these frequencies will approach 1/6 for each one. And that's actually there's a name for that. It's called the law of large numbers. And we'll come back and talk about that some more later. Now, on the activity I gave you for this unit, I'm having you simulate rolling a pair of dice. And there's actually a number of different ways this can be done on the calculator. And each one would vary in sophistication. So, like, for example, I'm just going to press clear now just to get to a kind of a clean slate. One thing, kind of a really simple way I could simulate rolling a pair of dice is just use the random number generator, randomint, twice. So in other words, choose randomint, same kind of a thing as before, but now I'm going to roll it twice and add those two together. So the sum of the pips here for rolling a pair of fair dice would be 6. And I don't need two different. I mean, I'm thinking, since each of the die are assumed to be fair die, having the same distribution, then each time I roll the virtual die on the calculator, I can think of it as being color coded, like in the game of Catan. One is red, one is yellow. So this could be like red roll is 5, yellow roll is 1. So the total is 6. And I can roll 2 more times. Now the total is 7, and now the total is 7 again, and now the total is 6, and so forth. And so I can do the 100 simulations in a very simple way by just rolling each die individually and thinking about it as red roll, then yellow die roll, and adding them together. And I would need to do 200 of these random numbers, and that would take care of it. There are more sophisticated ways to do it, and ways to do this more quickly. So another thing that you could do is have the calculator or get the random numbers and add them together in the same line. So in other words, I can come and get a randomint 1 to 6 and add to it another random int from 1 to 6. And now each time I press enter, that's a sum. So the first roll was a 10 of the paradise. The sum was a 10, the sum was a 7, a 9, a 5, a 7, an 8, a 9, and so forth. And as we go along, we want to be able to keep track of our rolls. And so one way to do it is just to use a table. And notice in the table, I have, let's see. I have the sum of the pips. So this column would represent each of the possible values of the variable. So rolling a 2 would mean a 1 on the red die and a 1 on the yellow die. Rolling a 12 would be a 6 on the red die, a 6 on the yellow die. We could get a 4, for example, by rolling a 3 on the red die and a 1 on the yellow die, or a 1 on the red die and a 3 on the yellow die, or a 2 on each die of the dice. So there's different ways these can happen. And let's see, what did we end up with? We got a 5, a 7, an 8, and a 9. So I can make tally marks here of 5, a 7, an 8, and a 9. My pen color is not very, let me switch that up here. Oh, let's just go with something dark. It shows up well. There's one tally, there's one tally, there's one tally. Go back to the calculator. So you have 5, 7, 2 9s, and a 10. And so this would be another way to represent a distribution in a table format. And then as we, I'm not going to do it 100 times in the video, the simulation, but when we finished here, we could put our final counts for each of the numbers. So maybe I'd have a 2 of 2. I mean, obviously I'd have a lot more tallies in these columns after doing this simulation 100 times. Now, I'm not asking you to do a table on the activity. I'm asking you to, well, I am asking you to do one table, but that's a little bit different. Sort of the same, but different. We'll get to that in a minute. Okay. Now, the next thing but the one thing I do ask you to do on the activity is to create a frequency plot. And so, for example, I lost all my tallies. I'll get some more off the calculator. So let's see, back to the pen. We'll get a few more random numbers here. 7, 7, and or random roll 7, 6, 10, 8. 7, 6, a 10, and an 8. So you could just record your results directly on the frequency plot, straight off the calculator like I'm doing now. 5, 6, 7, 6. And continue to do this for 100 repetitions and see what the graph looks like. And that shape of this graph is going to give us an indication about what we would expect the idealized distribution to look like, as in the first example with the fair die. Well, that's it for this video. Please message me if you have any questions.